Rate as a comparison. Learning goal. I can describe rate situations in a lot of ways. Let's look at an example situation. Liam completes a 5-kilometer run in 21 minutes. If he ran at a steady pace, how far did he run each minute? And how did you figure it out? So the first thing I'm going to pick up on is the question I'm being asked, first of all, is how far did he run in each minute? If I had just been asked, how far did he run? Well, that's already given to us. We're told he runs 5 kilometers. But since they're asking how far did he run in each minute, I know I'm looking for a rate. And since I'm working in kilometers and minutes, I'm going to assume the answer I'm going to get has to be in kilometers per minute. To solve the problem, I start with the information that I'm given. I'm given that he runs 5 kilometers in 21 minutes. Another way of saying that is that he runs 5 kilometers per 21 minutes. If I restructure this a little bit, I can see that that's the same as saying 5 kilometers per 21 minutes. It's no coincidence that in rate questions we use the slash as per, and we know when we have a slash like that, it's the same as division. So now I can put them as 5 kilometers over 21 minutes. I can also then separate that a little bit and say it's the same as 5 over 21 kilometers per minute. Now it becomes much more obvious that he's running 5/21, 5 over 21, so we've got a fraction there, kilometers per minute. Now all I have to do is this calculation of 5 divided by 21. Well, I know if it was 5 divided by 20, I'd be the same as 1/4, which is 0.25, so I know I'm going to end up with a number pretty close to that. If I do that division on a calculator, I end up with something like 0.23809, which if I round off just to 2 decimals would be 0.24, and that is kilometers per minute. So how did we do it? We took the information that we were given, turned it into a division question, and calculated out the division. Question 2. Suppose Liam increases the distance he runs by 0.5 kilometers per minute. Well, I think what they really wanted to say here is he increases the speed that he runs by 0.5 kilometers per minute, because obviously this is not a distance, this is a rate that we're given. So he's going to increase his speed by 0.05. So what we're saying then is that his new speed is going to be equal to 0.24 plus 0.05, which is, of course, 0.29. The second part of the question then says, how long would it take him to run the 5 kilometers? So with the how long would it take him, we know that our answer we're going to be looking for is going to be an answer in minutes, or in time, certainly. And this is where I'm going to think about my units a little bit. Right now I've got a rate in kilometers per minute, and I've got a distance here of kilometers. So whatever operations I do with the data that I've got the new speed that he's running, and I know I've got a distance here of 5 kilometers. So whatever I do with those two pieces of information, I have to end up with minutes at the end of it. So I'm looking for something that's going to give me minutes at the end. In order for that to happen, I have to get the kilometers to cancel each other out. So they have to disappear from my equation. So the first thing I want to do, I know that I need to end up with minutes. So I've got to get the minutes up top. So right now I've got 0.29 kilometers per minute. So I want to get my minutes into the numerator. So I'm going to go to 1. I'm just basically going to turn this upside down. 1 over 0.29 minutes per kilometer. And I'm going to multiply that times my distance, which is 5 kilometers. The kilometers are going to cancel, so I just end up with minutes left over. So I'll have 1 over 0.29 times 5 minutes. Another way of looking at that is also to say that's the same as 5 over 0.29 minutes, which if I do it on the calculator is 17.24 minutes. So what looked like a very small increase in speed of 0.05 kilometers per minute turns out to be a significant improvement from 21 minutes to 17.24 minutes. Choose a distance longer than 10 kilometers that two people are running. Choose times so that one person runs the same distance 10 minutes faster than the other. So I'm going to start off, I'm going to say they're going to run 10 kilometers, and the first person is going to run it in 60 minutes, and the second person is going to run it in 50 minutes. So what is each runner's rate per minute? Runner 1 is running at a rate of 10 kilometers per 60 minutes. And runner 2 is running at a rate of 10 kilometers per 50 minutes. If we want to convert each of those now into a rate per minute, for runner number 1, that's the same as saying 10 kilometers divided by 60 minutes, which is of course the same as 1/6 of a kilometer per minute. And if you want to do that math on your calculator, you end up with 0.166666 repeating, so we're just going to round that off to 0.167. Runner number 2 is 10 kilometers per 50 minutes, which is the same as saying 1/5 of a kilometer per minute, which is easy math to do, is 0.2 kilometers per minute. So we have two rates right now, both of them in kilometers per minute. The next part of the question asks us, what is the rate per hour? To get the rate per hour, we have to be converting minutes into hours. To do that, we multiply by 60. So we want to multiply the top by 60 and the bottom by 60. So if we've got 0.167 kilometers per minute, to get the minutes into hours, we want to multiply that by 60. But if we're multiplying the bottom by 60, we also have to multiply the top by 60. So by multiplying this bottom by 60, that gives us hours. And now we just need to multiply the 60 times the 0.167, which if we hadn't rounded off, would end up at 10 kilometers per hour. And if you think about it, that's what we started with here, right? Was 10 kilometers in 60 minutes. So there's our kilometers per hour. We kind of had that right from the start. The second part, though, the second runner, 0.2 kilometers per minute, multiplying both the top and the bottom by 60. By doing that, the bottom turns into hours, and the top goes from 0.2 times 60, which is equal to 12 kilometers per hour. Lesson summary. A rate is a comparison like a ratio, but the units are different. For example, 3 meals per day describes a rate because the units being compared are meals and days. $3.99 per kilogram is also a rate because it compares price to a quantity of an item being sold. We would often use the word per when saying a rate and a slash when writing the rate. For example, 90 kilometers with a slash and an H means 90 kilometers per hour. 6L slash flush means 6 liters per flush. 100 centimeters slash meters means 100 centimeters per meter. Like ratios, rates can be described in many ways. For example, if a heart rate is 65 beats per minute, you could also say it's 130 beats per 2 minutes, or 3,900 beats per hour, and so on. These are equivalent rates. One way to form an equivalent rate is to multiply both terms of the rate by the same non-zero amount. For example, to write an equivalent rate for a walking pace of 9 kilometers per 2 hours, an equivalent rate, if we multiply both the top and the bottom by 2, gives us 18 kilometers in 4 hours. A unit rate is a rate in which one term is 1. For example, a box of laundry detergent washes 37 loads of laundry. you could write the unit rate as 37 loads per one box. You can walk 1 kilometer in 12 minutes. A unit rate would be 1 kilometer per 12 minutes, or 12 minutes per 1 kilometer. Key terms. Equivalent rates. Equivalent rates are rates that describe the same comparison of two or more quantities in a different form. For example, a rate of 60 kilometers per hour is the same as a rate of 120 kilometers per 2 hours, or 1 kilometer per minute. Rate is a comparison of quantities that are in different units. For example, $2 for 6 items, or 80 kilometers per hour. Ratio is a comparison of two or more quantities. For example, if there are 5 adults and 3 children in a group of 8, the ratio of adults to children is 5:3, or written as 5:3. Term. In the context of rate, so when we're talking about rates, the word term means each part of a rate. For example, if the rate is 80 kilometers per hour, the two terms are 80 kilometers and 1 hour. Unit rate is when two quantities are compared in a rate. The unit rate tells how one quantity matches a unit of one of the other. For example, if it takes 60 minutes to walk 5 kilometers, the unit rate is 12 minutes for 1 kilometer. Your turn.